All right, Julian said he's back. I see his penguin there.
I'm
So
back.
if he could give his introduce himself and tell us about PC32 Color Forth with integrated graphics.
Hi everyone, my name is Julian Roca. Um, can you hear me? I'm sorry for the late
We can hear you
appearance.
fine. We can hear you fine.
Okay, I'm going to sync my screen and it doesn't appear. Let's see. Share. Now, can you see my screen?
You can see your screen. It's quite legible.
Okay, this is PC32. It's basically color for. I've been working on this language for quite some time now, and about what, like 6 7 years now. I just hadn't released it because I thought, people weren't interested or something. So the language is 32 bits and it's written mostly in assembler, and it's for Linux and for Windows. I'm mainly a Linux user, so I'm using that. um, the language is a native port, and you use blocks for the source code. Additionally to that, there is the editor and the 2D and 3D graphics, which was my main goal. I wanted to make games, so I made it so that 3D is easier to do. Aside from that, it has 485 lines of the core compiler. It's a very simple colorful compiler, and the rest is just C code to glue it to the OS. Now, if I go to the next block, the language itself, it has one dictionary. It differs from the traditional color for, which used two dictionaries, the execute compile dictionary. This one is just one dictionary, and you have a color to set the behavior. You can also inline words, and you have a very simple x86 compiler. The only thing you have to do is press F5 and you get the block you're in compiled. And the core and the assembler are just 9 blocks of source code. So now the editor is written in the language itself. It's 11 blocks of 1024 bytes and 11 blocks of shadow documentation. It uses counted strings for the words. So every word you see has its own count, is 16 bytes long maximum. And when you press the arrows, the cursor goes by word. The editor itself has 16 colors. Is one I wanted to have display a display mode, something like the old Mega Drive console, which was 4-bit. So that's why I did it like that. Aside from that, the numbers are pre-parsed. So the 10 you see here in the cursor, these are the actual byte representation stored in source that the editor, when it's rendering the block, it picks the number, converts it to a string, and prints it out. So you get behavior like, for example, you type something like this, but you type it in the number color, and when you move the cursor, it gets parsed into a number. So you also have hexadecimal encoding and fixed point. And you have a final flag for a custom display, number display, which I plan to use for floating point in the next implementation that I'm working on. You can also press escape and you get a command line. but it's not really visible here because of the blue bar that I have here. And you got also source lookup. So if you have a number or a word and you want to look it up, you press the key and it takes you to the block, and you press the, I think it's the end key, and it brings you back right where you were. Aside from that, there is 2D graphics. The language itself is fixed at 640 by 480 VGA resolution. The VRAM is mapped into memory as if it were a console. And we have a few different display modes. We have the 4-bit that is used for the editor and maybe for some color constrained graphics. We have the 8-bit direct display, which is the standard. We have is 2056 colors, but you can also use a palette for that. And finally, you have the full display. The 16-bit direct color is 2 bytes per pixel. So if I press F5, you can see that the editor is drawing lines inside the editor, and then it's rendering the block. This is because it uses the blue words. So let me show you. If I press F9, you can see that the blue words that are in the block. Up the top, I have the clear, which just clears the screen. Then I have the word for the mini logo, which is, if you're familiar with Colorfort, you are probably familiar with the logo. And this all gets rendered, and then the text of the other source code is displayed. So finally, there is 3D graphics for the language. It's immediate mode OpenGL. It's done through the C interface. I wanted to control the video card directly, but it's just impossible. It's just hell. So immediate mode OpenGL it is. And you can do about 10,000 triangles per frame without any optimizations. And you can do about 1,000,000 triangles per frame with using draw lists. And the pipeline is fixed. That means, for example, you can't really write a shader, so you have to use the traditional Gouraud shading, which is vertex per vector per vertex. You get the light direction and you compute the occlusion to that vertex. But you can also implement shaders, which I have. It's just not in this version. It's an older version of mine. And it's relatively easy to render geometry. You just read the data, ideally from a file or from a ROM that contains all the packed geometry. And you begin a triangle list, do a for loop, pass the command for the triangle or for the point to be rendered using a texture or using a color. And finally, you do a capture, and then you draw that frame, allowing you to combine, for example, 3D graphics and then text in front, because the 3D graphics are polygon based, but the text is immediate mode pixel based text. So if I go and press F5, you can see that we have a mesh with some color, vertex colors, in the background. And you can mix it with text. You can even mix it with other mesh buffers. So it's fairly simple. It's fairly straightforward. So if I press escape, now it's gone. And that's pretty much it for that. Now the future of the language. What I'm doing today, I'm doing documentation. I'm trying to make some tutorials. You can watch them on my YouTube channel. And I'm working on some actual, real games. I also have a few other versions working, which which were what I was spending most of the time of these past 6 7 years. I have the ARM thumb working on bare metal on a few processors, and I also have an FPGA implementation of the language, but that needs some more work. Aside from that, I haven't been able to get it to build on Windows. I have no idea why it doesn't build. It's probably due to some library or some linking. It's just a mystery to me, but I will probably get it built on Windows sometime in the future. There are other versions. There is a 64-bit version and the shader version. The 64-bit version used Vulkan, so I kind of abandoned it because if you look at the documentation for Vulkan, it's like 2,000 lines just to get a triangle, and it's just too much of a pain in the ass. So I just abandoned it. Or it needs updating, but it's functional. And I also have a Nintendo DS version, which was working, but the ROM was being generated from the 64-bit version, so I need to update it. And finally, I'm working right now on porting the compiler to the Dreamcast because I have a pretty cool game I'm making. So I wanted to port it there and hopefully sell it, get some copies out, and get some funding for further development of the language. So that's pretty much it for the presentation. I thank you for watching. This is my page, dscf.co.uk. You can get the source code for PC32 on the GitHub dscf prog. The language is BSD licensed, although I could license it MIT if people don't like the BSD license. And you can contact me at my email. And for sponsors, if you're interested, just check out my Patreon. That's pretty much it for the presentation. Thank you for watching.
Very nice. Thank you so much. Let me ask,
Okay.
you mentioned a YouTube channel.
Yes.
Can you maybe send that link to the chat?
Yes. Let me see. My YouTube channel is, because I don't have a quick name for the channel. Let me go to the page. And the channel is called New Tech Studio. The address is in the
Can you
chat.
can you type it into the chat? Great. Oh yes, I see
Yes.
it. Wonderful.
New
Thank
Tech
you.
Studio 9236. If
Questions for
there's any
Julian?
questions, feel free. Sorry?
I have a question. If you're up for taking a live one, this is great and fascinating. It sounds like you've taken lots of color forth inspiration. It looks like you've retained things like blue words and so on. Where it sounds like you've got a bunch of interesting variations on the approach, though. You said that the words are stored as counted strings. Is that did I get that right?
Yes, sir. They're counted strings. Because the compression that Color4 used is word based.
Yes.
So I wanted to get more than 256 words per blocks, right? So
Yep.
I get like 1024, and maybe I'm thinking in the future I could get like 1044 if I shrink the encoding to 5 bits or to 7 or 6 7 bits. But for now, it's just plain ASCII.
Very neat. I'm eager to check it out.
Well, thank you. If you can get it to build, it's just you need a 32-bit environment to build. That's being like a problem for me because to get it out to people, as you know, Linux is just you can just give them a file and say use it. They have to build it, and well, that's been a challenge.
Julian, how does it represent strings?
Strings are ASCII, but in where the space would be, you get the a packed like a count, which is 4-bit. So, and you get the tag for the color. So, for example, a string would be the tag number. I think it was 6 or 5, and the next nibble of the byte, you will get the count.
Oh. What is the color for tag number 6? Sorry.
Well, it's just an internal representation. For example, let's say tag 0 would be a definition, tag 1 would be a call, tag 2 would be a number, 3 would be a reference, 4 would be, 4 would be the string, 5 would be an assembler word, 7 would be the blue word, 8 would be, and then you go cycling between tags.
Okay, thanks. Yeah, that makes sense. So you have a separate tag for strings. Okay.
Yeah, yes, sir.
Travis has a
I've got a question.
Okay.
You said in one of your slides that you support the RP2040, right?
Yes, sir.
How are you handling execution of user code? Are you putting all the code you execute in a RAM, as let's say Micris Stellaris does? Where
Yes.
okay, so you are doing like what my own Zeptofort does, where it uses execute in place from Flash. It only puts its kernel in RAM to save more RAM space for the user, and also so that the user can have essentially arbitrarily large programs that they run.
Well, the thing is, the RP2040 version of the language was initially developed because I'm making something like a console, something. It's a keyboard, but it's also a console like an old C64. So I wanted to have the compiler inside the chip, and be able to manipulate code, to do things like that. I have it working 100%. It takes about, with the editor, I think takes about 30K of the 256K of SRAM. And I'm not using Flash at all because I am trying to use the PS RAM in order to have some a little bit more of a dynamic memory. So I'm not using Flash at all, or other than the boot code. So yeah, there's that.
Okay. I was just wondering, that's all.
Okay. Well, I think that's it. If there's any more questions, I'll answer them happily.
Don, you unmuted.
Yeah, that was Julian. That was fantastic. I really enjoyed that.
Oh, hey, Don.
But you have ported a version to the FPGA.
Yes, sir.
Are you porting it?
It's pretty much done. I just have to get the boards done. It uses
And what display
the
are
Ultra
you?
processor.
What display are you using? Are you using an SPI display or a parallel type
No,
of
it's
display?
VGA. I have an SPI. I have an SPI library, but I find it too slow because I wanted to do games. So it has to be VGA.
So you just use like 3 pins that are modulated for VGA type code, the VGA monitors.
Well, not 3 pins. I'm using an 8-bit DAC, 8-bit DAC. So it's
Oh, okay.
18
Uses Zach.
plus the sync. So there's that.
Very, very, very cool.
Yes, sir. Thank you.
So the performance of the FPGA versus using the processor, the microprocessor, do you have any numbers on the difference between the two?
Well, I'm getting about 42 MIPS, but you can pack about 3 processors in the 5K of the Ultra Plus 5K. But I'm thinking just packing 1 processor and taking the rest to use some sort of SIMD, because 3D needs that kind of bandwidth, and you have to pretty much have a custom instruction set to be able to do polygons fairly fast. So that's pretty
Yeah,
much
down the
it.
road, I'd love to see you put it on one of my Core 1 boards. Not ready for prime time yet, but a few months from now, maybe we can talk.
Yeah, man,
Yeah, I
that's
think
really cool.
offline. So without further ado, I think it's time to move on. Thank you so much, Julian. That was great.
Thank you.
Joe,
Thank you all.
introduce yourself. You're up.
Very good.